morning, everybody in the United States, or good evening for everybody in Europe. So I will explain you in more detail what we do with handling data in the principle of a data catalog. So what is the main purpose of being able to handle different data sources and then being able to do something meaningful is make your data findable in the first place and also actionable. And I will try to demonstrate that during this demo. So what is the agenda of today? So I will first start with a brief definition of what is a data catalog, how do we consider this as a concept, and also then in the next point, how OnToForce and with our product DISQOVER interpret this and how we position how DISQOVER can be used as a data catalog. So I will explain very briefly the architecture that is involved to make the data actionable, to unify data, to integrate data. A little bit more in detail about the data ingestion process itself, and then the ultimate goal is to bring data together in such a way that end users or data consumers could use the data and the available information in a self-service mode. Then I will go a little bit deeper into the data sources involved in this demo. We are mainly active in life sciences, so also the data sources that I will use in this demo are public data sources, but this is to make an analogy towards what we can do with internal data. And then finally, I will define the data types. So these are the abstract classes of information on top of the data sources, which are the most important ones here for this demo. And then finally a demo, and there is time for questions afterwards. So if we first start with what is a data catalog, this is the description or a definition I found at Gartner. And so in one of their Gartner reports, they define a data catalog as a repository of data assets, which can be used to discover, to describe, or to organize information. So it's quite a broad definition. It's not only for the pure usage of the data, but it's also about how to help and organize information. What you try to do, or what you try to enable with a data catalog, is that also data consumers, but also analysts, data scientists, and data stewards are able to use the data in a relevant way that they can generate additional value. So more information can be found here. The information will be shared also afterwards. So if you are interested, you can dive deeper into this. But this is, in business-related cases, relatively a general term. So how is the DISQOVER architecture here? That's part of the story of our architecture. How is the DISQOVER architecture related or involved in what we try to achieve here? Let me start with the biggest box on the top. So you have a private installation of DISQOVER. DISQOVER is available as software that you can install internally, locally at a customer site or in an organization. What means that you have a full-end solution which can ingest different internal data sources and which can unify this information in one big graph, one big knowledge graph. And as a result, we also have an attractive user interface where you can search and navigate through the data, and there are a number of possibilities to access the data also via in a machine-readable way. On top of that, we also have what we call here DISQOVER Data Federation, which means that DISQOVER data, which is available in a public version of our system. A public version means it's available for everybody. It's an open access model where we have a lot of open data sources, freely public data sources available for everyone. But the advantage of this is that we already unified this information. We already cleaned up or mapped the information in a certain way so that you can nicely integrate this and combine this here in a local installation. Very important here is that the information that we ingest in a local installation remains local, remains private. So you only are consuming the data in a unidirectional way. There is no data leaking away. What is important here, and these are highlighted in the kind of yellow, are the different roles of the people involved in the whole process. So A data steward is on top of his or her data sources and can help here, DISQOVER can help here to communicate with downstream users of the data, for example, data curators or data wranglers who would like to produce or generate certain formatting of the data for specific use cases. Subject matter experts can help here with streamlining the data, with mapping the data so that you have like a unified data model, which could then be ideally be used by different end users. So if we focus a little bit on one part of the architecture, the data ingestion, and the next slide shows here a pipeline which was built with, by one of my colleagues. So what you see here is the pipeline, and that's the software we have also as a front-end application, the organization of the different data streams, and on the left side you have different data sources. So in this example, we take three different sources as an analogy to internal data that we would like to organize in a data catalog. Three different sources which are processed via a pipelining system, this data ingestion engine, with different components to finally result here in the publication of this data, enabling the data in DISQOVER. What is important here is that in the last step, we define a number of what we call canonical types or data types, which are important. And a little bit later, I will explain you in more detail what it means. But the important here is that you have a full-fledged tool which allows you to investigate what is going on. You can add QC rules on top of that. It's quite robust. It can handle massive amounts of data. It's very fast. And it is the memory footprint, the hardware footprint is rather low. So it works quite efficient in what it can do here. Everything under the hood, and that's not directly visible for the end user, but everything under the hood is in a semantic web format available. We apply linked data principles and semantic web technologies. So we optimize the data, we manipulate the data in such a way, transform the data in such a way that it's ideally prone or ready for linking. So what is the end goal of what we try to do here? And that's where the data consumer or a subject matter expert comes into play, is that we can solve specific use cases. And important use cases could be a data searching, simply being able to find what you need. Is it in a complex way via filtering and following links, but searching for information? Reporting, generating dashboards, generating reports which are attractive for other people, so you're preparing data for other people, or doing more advanced things like analytics. Could be on the platform, because we have a number of visualization tools and analytics tools available in DISQOVER, or it could be via links to downstream applications. Examples here are Shiny or Jupyter, but it could be also proprietary software, licensed software that you would like to link, would like to link to. So the end user is not exposed to all these details about the architecture. They are using the platform DISQOVER, and that makes it a nice experience for an end user, where people who have a very specific request for data or searching can use the application, find what they need as a slice of information they are interested in, and then can eventually, if they want, do a downstream analysis. So what are the data sources we focused on for today's demo? These are public data sources, but you could consider them, all of them, as a kind of effort of a data catalog. The three data sources are the sequence read archive, previously known as the short read archive. Second is a gene expression omnibus. The sequence read archive is a more modern database or catalog of information. It's more focused on the newer next generation sequencing technologies, the data which is generated there in different projects and different experiments. Gene expression omnibus is already existing for a longer time. It makes the data, or it's a platform where you can upload array and sequence related data, which was, let's say, more used, let's say, before the SRA became available. But these are two systems next to each other. And then a third system is BioProject, another NCBI data source, which could also be linked to the other two data projects, but it's more focusing on project-related data. So it's ingesting there some data, and there are a number of links in between them, but it's not really possible to find a solution on the web where you can nicely combine the three sources together. And also having the possibility to link out to other related data types, but more about this later on. So what are the data types we focus on here? And this is a little bit an abstraction of what is available. There are more into this, but these are the main ones. For example, projects or bioprojects in our case here, projects which are grouping different experiments together. They are describing, or they are described what the experiments are about, the platforms which are used, etc. An experiment is a combination of testing different samples. Samples could be reused in different experiments, etc. This is a many-to-many relationship, which is also very specifically defined in every data source we handle here. And there are also some challenges here to nicely combine the data. But what is more interesting, maybe under the hood, is how the data is processed in such a way that we define a project. And so if you check here, if you remember from previous slides, the one with last step here to define a data type, we have here data bioproject. You see here how three different data sources are contributing via parts of their pipelines to the concept of a bioproject with properties, with conversions, etc. Then the next step is experiment. Same three data sources, but a slightly different part of the pipeline is producing the data and making it ready for an experiment. And then finally, a sample. Sample is here the last one that I would like to highlight. The three different pipelines again, which are contributing in their way towards producing the data ready for a sample. So how does it look then if you combine it with all the existing data? So here you have in darker blue the links between the data types we defined, and the data types are represented with icons. So every circle is a data type. A data type could be sample, experiment, and bioproject, but we also have like publication, we have like type of sample, type of technology, etc. There are also some hidden data types which are not directly visible, and which are only appearing when you land on a specific data type, but more about this in the demo. So this is the section of the data types which are defined by the local data. If we combine everything together, we get a slightly more denser graph where you see that what I just discussed here, the small icons with a house icon next to it, these are the local ones, are embedded, partially linked towards other stuff. And other stuff could be organisms, publications, genes, etc. So I would like to switch here from my slides to a demo. So I would like to start here with a fresh view and show you a little bit more what we do with a data catalog and how we organize the data. So a general introduction to our platform. This is the main screen you see after logging in. This is also the main text search bar. Here you can enter keywords, combination of keywords using Boolean strings. And what you will see is that you have a very quick filtering of the content that we made available. And what is the content we made available? This is defined and this is disambiguated with all these circles of information. So every circle represents a data type. So we have some locally defined data types, means only on this server available. This is a test environment for this demo, prepared for this demo. You see this house icon that we can change. But what is interesting here is that you can link immediately to 300,000, 400,000 approximately bioprojects, a number of experiments, a number of samples. This is not a complete data set from these three data sources. We took a snippet ready for this demo. We will eventually later on also load all this data on the public platform. But for this demo, we have a snippet of the data. But what you also see in addition are these other data types, and these other data types are not directly loaded or made available or physically loaded on this server. They are coming here, they are combining here with data federation. So before I go into a search, I will quickly go here to this data sources tab to show you this is the list of all the data sources we have a possibility to search in. So this is data which is in the public system, so remotely available. If I click on the location header, you will see that 3 sources are in-house or local. If I click on one of these sources, for example, Geo or Gene Expression Omnibus, you will see how many experiments, bioprojects, etc., how many data types are defined by Geo. So every source is doing a small or big contribution. You'll see here that NCBI bioproject has some additional links to publications, for example. This is the information that we capture from every source. And so we do this also for all the additional sources. So this makes it quite extensive. If you click here on ontology graph, you see the same kind of information, but now highlighted with all the different data types linked to each other. And then it can do the same thing here, showing what the contribution is of Geo, showing what the contribution is of SRA, and same thing for bioproject. So this information all comes together in a graph, but the most important thing is that you now can search the graph, can use it to filter and do analytics on top of that. So the example I would like to use is searching for a mouse gene. And I will first start with this and explaining this in a little bit more detail. EBF1, sorry. And I'm searching for EBF1. I'm just typing this as a string, so just a term. Could be many things. And what you see here is that we quickly do a filtering on top of all the data. So you are quickly searching, where do we find an occurrence of EBF1 somewhere in the data? And by choosing a data type, you dive into a specific subdomain or a specific type of information, and you do not have to bother about the rest. What is important here to mention, the differences in highlighting. If you don't have any highlighting at all, you don't find a result. So this is very clear here. If you have a white background, you find simple annotations or simple occurrences of this string. So this search string is just found here 105 times in bioproject, somewhere in the description, somewhere in an annotation. It's not containing the name of a single concept, of a single bioproject. This is here something different. In sample, we have one occurrence of EBF1 for sample and 95 times a link or somewhere a retrieval of that string in the annotation of samples. So there are 95 samples which have EBF1 somewhere as a hit. There is one sample which has the name or synonym EBF1. Same thing for gene. We have a lot of gene hits, but there are 235 genes which have the name EBF1, and these are typically all homologous genes within different species. So how does it work? I will first go a little bit into the related data, the public data. So let me click and let me link to gene. So I select gene and I'm going here into the related information to gene. What you see is a dashboard constructed of different parts. You have here your search bar available. You see like a number of hits in a representative way. And you have here a number of links. So what it means is that this EBF1 gives you 293 different genes, and now I can filter. For example, I can select an organism, show me all genes in mouse. So that gives me 19 different genes, and if I scroll down here, I see the list of all the genes which are relevant. One of these genes is EBF1 itself, so this is what we call a semantic hit. This is an exact match. The other ones are genes where somewhere in the annotation and related information, EBF1 is mentioned. What you see is a dashboard which is dynamic in the sense that if I'm selecting here something in another part of the dashboard, everything adopts to that. so I can nicely go deeper into this. I have the possibility to follow links. So my 19 resulting genes are still linked to a number of proteins, to a number of diseases, but also to a number of pathways, and so on. If I select here EBF1, I see how the information is organized. And what is now interesting is taking a look at what are the data sources which bring together certain information. So I see here EBF1 as a gene, and I see that we can highlight this with this toggle, that different data sources are contributing. So with color codes, you can distinguish which data source is contributing to what type of information. So if you take wiki pathways, you will see a part, and this can be information which is stored somewhere in the links, etc. So what you get here is from the single gene, I can link to other data types, for example, to pathways, for example, to model organisms, but also to publications and to bioprojects. And these data types are defined with this house symbol, so they contain some local data, some internal data. So if I follow this link here to bioproject, I would see 2 bioprojects. And let me just quickly go into that. And then I will see some highlighting information about two pieces of information which are directly related to this gene, but they are not external data, these are local data. But let me start again and start off again. So I'm searching again for EBF1. And instead of going to gene or to something other related in the remote data, let me go to bioproject itself. So I start with bioproject, and now I see 105 different bioprojects where EBF1 is found. So if you remember, I only had 2 EBF1 2 bioprojects which were related to the mouse gene EBF1. This is what we find with a pure text search. So sometimes links are available, sometimes links are not available. What you have here for these 105 different bioprojects is, for example, a relationship to a number of experiments. So these 100 projects are related to 10 experiments. It would be more if we have a full load of the data, but it's more about the principle and how we can organize the data. So if you think about a data catalog where we organize the data here in a hierarchical way, different sources are brought together, different data types are linkable to each other. So a project is a combination of different experiments. If I click here on a single project, so this is also a way to represent the results. This is an expandable view where you can see the results compared to what I just have shown you, that the results could also be at the bottom. What you see here is, if I'm just click on any result, you see here a combination of data. For example, this is a description of a bioproject. This is coming from NCBI bioproject, all this information, and it has a link to a publication and an organism. If I take another result, for example, the first result, I see another subset of information coming from the same source, just a repetition of what I just showed you. I have a number of filters here, same principle, and I can also highlight very specific origins of the data. For example, show me all the data, show me all the results, which have at least a link or which are at least receiving information from Gene Expression Omnibus. So I'm clicking here on another result, and you see here that we combine certain data. So this is an overlap in data. So this is a concept, a single project, which is retrieving or receiving information from NCBI bioproject and Gene Expression Omnibus. So what is interesting in this is we have a possibility to link out or follow a link out to the original information on the internet. So this is what we have here. This is the bioproject information. But at the same moment, we have the possibility to link towards, for example, or see the information of Gene Expression Omnibus. And so what is interesting here is that we can use all this information for a subset of data We can also download the information. It's available in CSV format or in Excel format. But more interestingly, we can follow links and we can filter here. So let's say that I would like to see all the data which is related to Homo sapiens. So instead of going for the mouse gene, I'm going now for the human gene, and show me, for example, for Homo sapiens, the different related experiments. So I have 4 resulting projects. Show me the experiments related to these 4 projects. Also 4 experiments. I'm now here looking at experiments. You have other filter possibilities. You see here who has run the experiment, so who is the contact, which type of machinery is used, what are the data sources, and I can link here towards information, again here for a single experiment from NCBI Bio project to gene expression omnibus. I was also explaining that we would like to go for a self-service mode where people could use this information to combine this with other applications, other analytics methods. And for people who are a little bit familiar with this type of information, we can link out to other applications. An example could be, and I just took an open access example for this, is that we take this gene term and that we can link this to another application. How can we do this? We can define here a button, this instant link post button, where we can send a post message to another web-based application, packaging a number of properties where we can open another application with, and that we can start an analysis in another application. So this is completely configurable. There is a possibility to use a microservice in between to have a better mapping and to have more flexibility in mapping. But the result could be that you start an application like this one. This is an open access, open source application, Shiny Geo. This is running as a Docker container on my local computer here, but I could use this as an example to say, okay, I would like to go to this results and I would like to load here and start from here to do a downstream analysis. So this is the whole idea about how we can link to other applications. So a post link can be made to any web application which is allowed or which is able to do that. We can go further even and say, okay, certain results which are derived here or resulting here could be re-ingested in the system via the pipeline. This is a possibility. So if you do a downstream analysis, you annotate the information, we could re-ingest this as an additional data source or an update on certain data. Let's go a little bit further. I have an experiment. An experiment is related to a number of publications, but is also related to a number of samples. So third part, these are the different samples we have here. So this is completing the story. We started with a project, then an experiment, and here you have the combination of samples. Interestingly also is that you can filter here depending on the types, the age of the samples, if that is available, experiments which are running, the projects which were involved, if this is well annotated, and potentially also the taxonomy, the type of species which is used. And so here you get some descriptions about this information, together again with links towards other stuff like the experiments, the related organism, and the project. So this is what we have with the local data. A little bit more about and linking towards other stuff. I made a number of searches, and you see this here on the left. So every dashboard I created is stored. It's stored chronologically depending on when I started or first used or produced the dashboard. So if I go, for example, one step back, I see here a link to publications. So I can link out and see the related data for publications. Okay. This is almost the end of what I wanted to say to you. So important here to summarize what we have seen. We could show you here that for a number of data sources, we bring together the different data, the different contents. So we have a number of data types defined. The 3 sources are contributing to different data types. We make it searchable. We make it possible that you use different search terms to search across all this data. And moreover, you can extend with all the public data which we combine. There are a number of links created, so there is a logical story or path between all this information, and there is a possibility to downstream, to link to downstream applications, to do a continuous analysis on that, or to download the data. So this is what I wanted to tell you. If there are any questions, please raise your hand. There is a possibility to use in the Zoom application this feature, and then Marit will further moderate here. Thanks a lot.
I see one question. Yes, please.
Hi, this is Sharang, and thank you very much, Philip, for this really good demo on DISQOVER. I have a question around small molecule searches. I did see a sample somewhere down here, and a chemical icon in the dashboard here. Is it possible to search via structures or sketch a structure and run searches against that?
Absolutely. This was not part of the demo, but you have a possibility to configure the system with a plugin that you can do a structured search. So this is typically a text-based search, but you can add a plugin, and we typically work together with Chemaxon, for example, to enable this. So you can do, configure a canvas to draw, and you will be familiar with that, I assume. And then you can send your request to a third-party service to do a similarity search or a substructure search. The results are returning back into DISQOVER, and then you can continue. So this is something we do already for some customers. If you are interested in that, we can also give you some more details about this.
Thank you.
There is a specific demo also. Yeah.
Thank you. I just sent in a request through your web form asking for one. Thank you very much.
Very good. We will follow up on that.
Thank you so much, Sharang. I see another question from Michael. Please do.
Oh, hello. I think I'm unmuted. Hi, thank you once again. I had a question about your downstream hooks for pulling data in for analysis. For some of us in large organizations, we're prohibited from hitting a lot of the sources like geo directly, and are prefer to use a local copy so that we don't get locked out. You have a lot of users to happen. And so can that be configured to potentially to say retrieve the web page for when linking out directly, but to for any sort of programmatic access to download data, do that from a local space?
Yeah, so do you mean that it can be restricted to do that, Mike?
Yeah, we tend to get locked out if we hit things like PubMed too often, things like that.
Yeah. I understand what you mean. So you are like, let's say the traffic of several thousand people are, let's say,
they all go through like one
pointing towards, yeah. There is definitely a possibility in configuration if you allow for linking out or not. One of the possibilities we have, and this is something we haven't discussed here, is using what we call user security groups. So the link could be part of that only a subset of the people who have additional rights or whatever, and elevated rights, could have the possibility to do certain link outs. So this is definitely a possibility to embed.
Yeah. I mean, mostly happens for like download requests and such thing. You know, like,
yes, it's similar. Like if you have certain licensed information, that only one department or one group can only see this because the license is not allowing to use broadly inside the organization the data. So this can be on different levels configured.
Thank you.
Thanks, Mike. Other people?
I don't see any other hands, but if there are questions, please raise. I don't see any new questions coming up. So I think then for tonight we are good to go, and we can end this webinar. Thank you, Philippe. Thank you for presenting today's webinar. Thank you all for attending this webinar, and we'll make sure that it's available afterwards. Enjoy your day, enjoy your evening, and hope to see you again. Bye-bye.
Thanks a lot. Bye-bye. Take care.